If you remember, the AC Ranger and Ranger Neo meters have always been compatible with FM signals, meaning that you could tune the carrier, demodulate the carrier, listen to the FM station, and get the signal level for that carrier, for that FM carrier. But now with this advanced FM option, we are doing several things, several new things. First of all, if you go to the measurements mode, you will get some additional measurements besides the signal level. You will get the signal level as well for the demodulated MPX, the demodulated multiplex, and then you will get as well the calculation of the FM deviation for the MPX and for all the different subcarriers that form the MPX, the multiplex. For example, the left plus right deviation, the left minus right deviation, the left and right carriers separately, the stereo pilot, and the RDS pilot, or the RDS subcarrier. Then, if you want to see all these carriers in the spectrum analyzer, we have created a special tool, specific tool for that, which is called the FM MPX spectrum. And here what you see is the whole spectrum of the MPX, of the multiplex, with all these different carriers that form the whole MPX. For example, here on the left, the first component, the first subcarrier, would be the left plus right subcarrier. Then this narrow band peak, this is a stereo pilot. After that, all of this is the left minus right subcarrier. These two peaks here together is the RDS subcarrier, and you can have even more data after this. You can have some more data, another carrier. The whole thing together usually goes up to 75, 80 something kilohertz, depending on whether these additional subcarriers are there or not. Something very interesting to calculate in FM is what is the distribution of the MPX FM deviation. What is the distribution of the values for this measurement? And this we can offer in this tool. We go to Tools again, to FM histogram. Here what you can see, let me explain to you quickly how we calculate this. What we're showing here is we take measurements continuously over the deviation of the FM MPX, and what we want to show you is what are these values, how they distribute. How some of them are maybe 75 kilohertz, some of them are 80, some of them are 60. So we want to see what is the percentage of each one of them that are showing up. And there are two ways to calculate this. If you go to Advanced, you can see these two ways, and these two ways are standardized. There's a specific way that you should calculate that it's defined in an ITU norm. One of them is this 50 milliseconds, and the other one is all samples. I'll explain you what we're doing when we calculate with this max 50 milliseconds. What we do is we take a period of 50 milliseconds, and we take several measurements over the FM MPX deviation. We take several of them during that period. And when the period is over, we keep the maximum of those readings. And then we do it again, and so on over consecutive periods of 50 milliseconds, and over each of those periods, we keep the maximum reading. And with all those readings that we keep, we plot this graph. So now what we should do? Okay, what we should do is we should select a threshold. For example, let's say that we don't want our FM carrier to have an FM MPX deviation higher than 75 kilohertz, because that's a very common threshold to use in FM. So you select it here. Actually, if I move right, I could select a lower one, 75, 71. I will select 75. And for that specific value, what I see, what the meter is showing me is how many of all these readings that I took, all these measurements that I took, that I kept the maximum of each 50 milliseconds period, how many of them have an MPX FM deviation of exactly 75 kilohertz? And that's 1.5%. And how many of them have an MPX FM deviation of 75 or higher, which is 78.1% of those readings have an MPX FM deviation higher or equal to 75 kilohertz. The samples 1, the 1.7, comes from the yellow plot, and the accumulated comes from the green plot. Now, I told you that there were two ways of calculating this. The other way, all samples, here the meaning of everything I explained is exactly the same. The only difference is when I'm taking all those measurements over the MPX FM deviation, I don't just keep the maximum reading of every 50 milliseconds period, but I keep all of them, and I use all of them to plot these graphs and to calculate these numbers. So that's it for FM. Those are all these new advanced FM tools for testing FM carriers. I hope you find this quite exciting, and I'm sure you will find it useful.